Day 6 of 90. Today we are building proper error handling and logging into Python security tools. If your scanner crashes on a socket timeout or your credential tester dumps passwords into plaintext logs, you have a problem. By the end of this video you will have patterns for granular exception handling, custom exception classes, structured JSON logging, log rotation, syslog integration, and credential redaction. Let us start with try-except patterns for security operations. When you write a port scanner or service prober, failures are expected. The target might be down, the port might be filtered by a firewall, the service might speak plaintext instead of TLS. Each of these is a different situation and your code needs to distinguish between them. A socket.timeout means packets are being dropped, probably by a firewall. That port is filtered. A connection refused error means the host sent back a RST packet. The host is up but nothing is listening on that port. That is a closed port. An SSL.SSL error during a TLS handshake means the port is open but the service does not speak TLS. You fall back to plaintext banner grabbing. And an OS error is your catch-all for anything unexpected, like a network interface going down or a permission issue. The point here is that each exception type maps directly to a real network state. If you collapse all of these into a single exception block, you lose all of that operational intelligence. Your scan results go from useful to useless. Now let us talk about custom exception classes. Once your security tooling grows beyond a single script, maybe you have a scanner module, an authentication module, a reporting module, you need exceptions that carry context through the call stack. You create a security tool error base class. Then you subclass it. Authentication error takes the target host, the authentication method, and the failure reason. Scan timeout error takes the target and the elapsed time. When you raise these, you use the raise from syntax. That is raise authentication error from the original paramiko.authentication exception. This preserves the full exception chain. When you catch it 3 layers up, you can inspect both your custom exception and the original library exception that caused it. At 2 in the morning during an incident, that chain is the difference between fixing the issue in 5 minutes and spending an hour guessing which layer broke. Structured logging. Plaintext log lines are fine when you are running a single script in a terminal. Once you have 10 tools feeding into an ELK stack or a CM, you need machine parsable output. I build a JSON formatter class that extends logging formatter. Every log entry comes out as a JSON object with a UTC timestamp, the log level, the logger name, the message, the module, and the line number. If the log record has a custom event_type attribute, that gets included too. For the handler setup, I use a rotating file handler. Set it to 10 megabytes per file with 30 backup files. That gives you 300 megabytes of log history before anything gets overwritten. Predictable disk usage. Then I add a syslog handler pointed at the system's syslog socket. I set this one to warning level and above. That way, routine debug and info messages stay local, but anything that needs attention gets forwarded to your centralized logging infrastructure. If the tool host goes down, your alert's still fired. The last critical piece is redaction. Security tools handle credentials, API tokens, and PI. If your logger writes a raw password into a log file, you have created a new vulnerability. I build a redacting filter class that extends logging filter. It holds a list of compiled regex patterns. One catches password equals something. Another catches token equals something. A third catches email addresses. In the filter method, it runs every pattern against the log message and replaces matches with a redacted placeholder. You attach this filter to your logger once, and every single log message that passes through gets scrubbed automatically. No need to remember to sanitize. in every individual log call. Combine all of these patterns and you get a proper audit trail. Valid credentials found during an audit log at warning because that is an alertable event. Failed authentication attempts log at debug for completeness. Timeouts log at error because they might indicate the target went down mid-scan. Every entry is structured JSON, redacted, rotated, and forwarded. That is day 6. You now have production-grade error handling and logging patterns for Python security tools. Granular exception handling, custom exception hierarchies with chaining, structured JSON output, rotation, syslog, and credential redaction. Tomorrow on day 7 we will work with files and directories for security automation. See you then.